Alright, so welcome to my first Arduino video. Today I'm going to be talking about this ultrasonic sensor and how to use it with your Arduino board. I'm going to be using an Arduino Uno today. If you want to follow along with what I'm doing, all you need is the ultrasonic sensor, the Arduino board, and 4 wires which are female to male, and also a computer to program the Arduino, and a cord to connect the Arduino to your computer. Alright, so we'll start off by wiring up the ultrasonic sensor. So it has 4 pins. Well, this one has 4 pins. You can get one that have 5, but we're going to be using a 4 pin. So it has a VCC, trig, which stands for trigger, echo, and ground. So the VCC, you just want to hook 5 volts up to it. So just hook it up to the 5 volts on the Arduino board. Then you can connect ground to ground on the Arduino board. So those are connected to 5 volts and ground. Then I'll explain what the echo and trigger do later, but for now, just wire trigger up to pin 5, and it doesn't really matter what pin you wire it up to, but I'm gonna go pin 5, and then for echo, and we'll wire echo up to pin 6. So just to explain the basics of how this works. So it's an ultrasonic sensor, so it sends out a sound wave that we can't hear, and then so you send a high trigger through the trigger, and then it'll send out a sound wave, and depending on how many microseconds it takes for that to bounce off something and bounce back, you can calculate the distance of in centimeters. We're going to calculate it in, but the echo is what detects the sound when it comes back. Alright, so now we can look at the code. So at the top of the code we set some constant integers. So we set pin 5 as the trigger pin and pin 6 as the echo pin. Then we set some variables, so a long variable as duration, because it's going to has lots of digits in it, because it's measured in microseconds, and then an integer as distance, that'll be our distance in centimeters. So in the setup, we've set trigger pin to output and the echo pin to input. Then we begin the serial at 9600 baud. You don't have to have that if you don't want to check, but it's very useful if you want to check the distance. So then in the loop we have digital write, so we set the trigger to low for 2 microseconds just to reset it, and then we set trigger for high for 10 microseconds, and then set to low again. So that sends out the pulse, and then we make the duration equal to the pulse in of echo at high. So whenever echo gets high, so when it receives back the signal from the trigger, it'll stop this pulse in timer, and that'll be in microseconds, so duration will be set to the microseconds of that. And now we can set the distance to the duration divided by 29 divided by 2. We divide it by 2 because it takes the time for the sound to get sent out and bounce back, so we only want half of it, so to see the distance. And then it's divided by 29 because if you divide the microseconds by 29, that equals around about 1 centimeter, so 29 microseconds equals 1 centimeter, according to the speed of sound. And then, so the duration divided by 29 divided by 2 will equal the distance in centimeters, and then we write that in the serial port. So we'll do the distance and then centimeters. So now if I upload that code to the board, and open up the serial port, so now it's showing me the distance. So it's saying 26 centimeters, and it's looking at my camera. So if I get a ruler and put it in front, now it says 15 centimeters, and as I move this slowly forward, it'll keep counting down. 9 centimeters, 8 centimeters, 6, 5, 4. Once it gets about 3, it gets a bit jittery, but it can accurately measure about. See, it starts reading out random distances. You can accurately read about 3 centimeters to 400, I think. I haven't tested, but I think I read that somewhere. So yeah, so this is how you wire up and use a Arduino ultrasonic sensor. You can use it for different projects like self-driving cars,